When in a previous video we talked about actuators, we said that the most popular ones were based on electric motors. So let's speak a bit about these electric motors. Although there are different types of electric motors, all of them use the same principle. They use the forces and torques that get generated when an electric current flows through a magnetic field. The torque or the force or the power that we get depends on three elements, three factors. First, the strength of the magnetic field. Second, the intensity of the current in the windings. And third, the length of conductors. As I said, there are different types of electric motors, but we differentiate between alternate current motors and direct current motors, or AC motors and DC motors. And while in the case of AC motors, the speed you get is usually constant, in the case of some direct current motors, that speed can be controlled. So we tend to use more the direct current or DC motors than AC motors. But there are also a third type of electric motor, that are stepper motors. In the case of other type of motors, the speed or the movement is continuous. But in the case of stepper motors, they move in little steps, in little angles. They vary in just in step, like if they were jumping. So in every moment, the angular position of the motor of the shaft is known without no need of feedback or monitoring. And so these direct current motors and stepper motors are the most used ones. And in the case of these stepper motors and some kinds of DC motors, the movement or the speed or how they behave can be controlled through digital microcontrollers and digital microprocessors. And the way that microcontrollers or that microprocessors know what they must ask the motor to do depends on the kinematic equations we speak in a previous video.